Okay, welcome, Elliot, and welcome, Milgros, and hopefully we'll get some more. This is the week 9 webinar, and the plan today is to go over chapter 11, which is the chi-square distribution. And I'll also answer and talk about project questions. One main thing is the project 2, which is a big part of your grade, is due on Sunday. So hopefully you guys have a good start on it already. A couple recommendations. One is that if you haven't gotten started on it, don't assume that your partner is still around. Make sure you contact your partner, make sure you're still working together if you want to use the same partner or partners from project 1 so that you don't end up without a partner. So that's absolutely number 1, is to make sure that you and your partner or partners, 3 is better than 2, are ready to go or going, hopefully. So that's the biggie. The other is, again, you don't have to do a survey. You can if you want. But if you are going to be collecting data from a website, for example, you're collecting data, not statistics. So it's not enough to find out the mean or the percent of all the people they asked. You have to find out what the quantitative answers were to each individual person. And a lot of times you find that in some kind of attached spreadsheet. Okay, so that's just a note. Or you can collect data by going online and looking one at a time for a bunch of different things that you're interested in. Okay, welcome, Susie, by the way. So that's just a big note about the project. A few of you have been thinking, oh, I'll just go grab data from online, except you're not grabbing data, you're grabbing statistics. And for this project, you have to grab data. So if you don't have a bunch of numbers to put into the column A and the column B in the spreadsheet, then you're not collecting data. So are there any questions at all about project 2? The best for getting the project in is tomorrow night. Because Friday, I'm pretty much booked. My office mate's back in prison, so I have to sub for him. Teaching in the prison, he didn't kill anyone. So I'm going to be subbing for him, and I'm pretty much booked from morning until night teaching. So that's why if you get it to me Wednesday, tomorrow night, then I can look it over Thursday. It takes me time to read it, and then give you lots of suggestions on it on Thursday. Okay, so that's the idea. If you wait until Thursday night, then that's pretty much too late, because I'm going to be teaching all Friday without a break. I'm going to be really tired, actually. So that's the kind of timeline. And my suggestion, as I always do, is don't think about Sunday as a due date. Think about Saturday as a due date, so that you turn it in a day early, and if something goes wrong, you have the extra day, but hopefully nothing will go wrong. So you always want to think about it and kind of turning it in an earlier time. And that's a good life skill, by the way, not just for projects, but anytime you have a big thing going on, waiting until the last minute, things can go wrong. Okay. And in particular, for example, I don't know if any of you are affected by the fire, but I know that I have some students that have been evacuated already. And any of you affected? If you're in Tahoe, you're not, which is nice. Yeah. LOL is not the right. I don't laugh on that one.
Oh no, that was to Elliot's. I'm still learning that skill comment.
Oh, okay, that's a better.
No, the fire's not funny.
No, we shouldn't be laughing about people evacuated from the fire. No. Okay. In fact, my father has been evacuated, but hopefully his house is okay. So again, it's a big part of California, north and south. And in this class, I have a lot of people from all over, most from California, one from Australia, one from Alaska, but most from California. So again, I understand if it happens, keep in touch. And the good news is wherever you are, usually you can get online. Okay, if you were, say, at Sac State, they're closed down. So is East Davis, so is Butte College. A lot of places are closed down. You're in Sacramento? Schools are closed, Elliot? Yeah, so I know it's bad. So are there any questions about the project or anything else? Okay, so I want to talk about chi-square tests. What we have been focusing on pretty much since the beginning of the quarter, except maybe the first week, is two kinds of survey questions. One kind is the quantitative survey question. That would be like, how much time did it take for you to register for this class from the time you heard to the time you registered? And that would be a number like, it took 6 days or something like that. The other kind of survey question we've been dealing with a lot is the yes-no survey question. That would be something like, are you ever planning on taking another math class in your life? And that's a yes or a no. But this week is different. So this is the week that we go and we talk about survey questions that are often qualitative. And there is a way of dealing with qualitative survey questions. And I'm going to give you some of the types of analyses for that, 3 of them actually, for qualitative survey questions. And what I want to do is I'm going to share my desktop. One of the things about this chi-squared, which is what we're going to do, is it's very technical. It's not something that you're going to read in a newspaper, you know, just online newspaper, see in the news, or, you know, just be at the grocery store and be doing chi-squared. It's usually done in research publications. So when you're looking for chi-squared, and that's why it was a requirement for this particular week in your post, you want to look at research articles because that's who uses chi-squared. And in honor of our forest fighters, firefighters, I'm going to share my desktop to an article I found just about 20 minutes ago. So let me grab that. And as you might guess, it uses chi-squared. So let me just make sure we're good. There. Okay, so the article's title is Firefighters Post-Traumatic Stress Disorder and Barriers to Treatment, Results from a Nationwide Total Population Survey. Okay. And this is a research article in PLOS 1. I'm not exactly what it is, but it's a researcher, there's an editor and the whole bit. Okay, so what they did is they did a study, okay, and they want to find out, they want to compare people with PTSD to people without PTSD on different qualitative issues. Okay, and people meaning firefighters. And that's what they've done. So I thought again, in light of the big awful events that have been happening, I want to take you to a table where it talks about a lot of this stuff. And these are the characteristics of firefighters with or without current probable post-traumatic stress disorder. And there's lots of different characteristics. So for example, there's demographic, age, gender, there's career, hire rate, rank, working at cities, years since employment, all kinds of different characteristics that you can have. And many of these are qualitative, okay? So for example, the last one, functional impairment in family relations. So the survey question is, have you had functional impairment in family relations? And people's answers might be not at all, slightly, moderately, or extremely. Any questions on that so far? So in particular, this is qualitative. It's not a yes or no question, right? Your answer might be moderately, which is a word. It's not yes, it's not no, it's not a number. But it doesn't mean we can't do statistics. And what we want to do is we want to see, for example, I want to look at this last one. We want to see, is there a difference in the distribution? Is there a difference in the distribution between post-traumatic stress disorder people and non-post-traumatic stress disorder people? Or in particular for this study that they used, they wanted to see if these two categories, being post-traumatic and non-post-traumatic versus the answer to the functional impairment, are they independent or dependent? So I don't know if you remember, but in chapter 3, and don't you hate when I like go and talk about some chapter that's been a long, long time ago? In chapter 3, we talked about looking at data and looking at variables being independent or dependent. Do you remember doing that? Okay. It's important you remember because it could be in the final exam, which is not too long from now. Okay, so that's something to note, is that if you want to find out if two things are independent or dependent, well, these are whole categories, not one individual thing. And the way you do that is what's called a chi-squared test for independence. And what they did, and you'll notice, by the way, they used chi-square tests. Okay, and my guess is this would be a chi-square test for independence. And what they found is that the p-value was less than 0.001. So by the way, what does that tell you when the p-value is less than 0.001? I don't need to tell you anything about chi-squared independence. I just need to see the p-value, and you should all know.
Reject the null.
Yeah, it means we reject the null hypothesis because we have a very small p-value. And in this particular case, the null hypothesis is that the answer to functional impairment in family relations is independent of whether they're PTSD or not PTSD. And the alternative hypothesis is that those two different category types are dependent instead of independent. And when you have a p-value tiny like this, we can reject the null, and we can say, yes, there is statistically significant evidence to support the claim that being PTSD or not PTSD and functional impairment in family relations are dependent. So have I lost anyone there? So I know I go kind of fast sometimes, and some of you complained about that on your extra credit question. Any questions on that? So we know those are dependent. So that means that if we're looking at functional impairment in family relations, it makes a difference whether they're PTSD or not PTSD. Okay, what it doesn't say is how it makes a difference, but we know it makes a difference. Okay, we know there's a relationship between those two things. Any questions at all on this idea?
Well, all we're coming to the conclusion for is that there's something connected between PTSD and functional impairment. But we don't know how much or what it looks like. Is that right?
Yeah. So I want to remind you of the title of this class. What do you call this class? What's it called?
Math 201.
No, that's the number for the class. Remember the title. Elementary statistics. Exactly, Elliot. Okay, this is called elementary statistics. So if you want to learn more and find out now how do you go and look at the details of why they're dependent, then you need to take advanced statistics. Okay? And that I can't get into because that's not this class. So sometimes especially as we get to the end of this class, what about if you wanted to after this, most of the time I'm going to tell you, take the next statistics class at your university. Does that make sense? Mm-hmm. So sorry if I'm not going to tell you, but there are different tests for doing exactly what you're talking about. Okay. But we're keeping it elementary, and we're just deciding, is it independent or is it dependent?
Okay.
Okay, let me tell you one of the reasons why you might care. One reason is if you were to say, want to do a study about functional impairment in family relations, and they're dependent, then you need to stratify by PTSD or not PTSD so that you can make sure you don't have the bias of that issue. Whereas if they're independent, then you don't need to stratify by that category. Does that make some sense?
Yes.
Yeah, because again, if they're independent, who cares? You can have everyone with PTSD and it won't make any difference in terms of bias. But what we found is they're dependent, and then it does make a difference. The other thing, yeah, question?
Yeah, it doesn't matter that the population is so much bigger on the non-PTSD.
That's a good question. So this is very similar to the yes and no questions. All that matters is that all of what we call the expected counts are bigger than 5.
Okay.
Okay? It's okay. And in fact, this is a kind of study, what they probably did is they just surveyed a whole bunch of firefighters. Does that make sense? Most firefighters don't have PTSD. Do you agree?
Yes.
So when they surveyed a whole bunch of them, they're going to get more that don't have PTSD.
Yeah.
So to try and get the exact same is kind of not reasonable in this case because they're not the exact same. Yeah, just like when you're doing a test for 2 samples, like for your project, by the way, if you're doing independent data, they don't have to be the same sample size, right? Only when they're paired. This is not pairing, by the way. This is very similar to the 2 sample t-test. Does that help?
Yes.
Very good questions, though. Very good questions. Okay, any other questions about this? Any questions? Okay, so one thing, by the way, notice I got p-values on everything. They also have confidence intervals. I'm not going to get into that. That's more advanced. But what we're going to need to do is find out how do you get these p-values. Any questions on that? Okay, so what I'm going to do now is I am going to reshare. And let's work on a problem. Let me go grab one. And this one's not going to be a test for independence, as we'll see in a bit. It's going to be one of the other chi-squared. Okay, so the question is traffic equally bad in the north, south, east, and west shore? And by the way, if you're not from Tahoe, that's kind of how we do, that's how we talk about Tahoe. We have 4 sides. And the question is it just as bad everywhere? Because if you live in Tahoe, you know that traffic sucks, okay, especially in the weekends. Okay, a count of 600 randomly selected cars in the Tahoe Basin found that 170 in the North Shore, 212 in the South Shore, 110 in the East Shore, and 108 in the West Shore. Any questions on that? Okay, so first thing, what is the survey question? It's very important to be able to get that down. What's the survey question?
Well, it's going to be yes, no.
It's a good try, but it's not going to be yes, no. So it's don't get confused between the survey question and the question of the study. This is a survey question. What are you going to ask the driver?
Oh, whether or not they think the traffic's bad.
No. There we go. Elliot's got it. Which part of Tahoe was your car in at the time? Does that make sense?
Mm-hmm.
And your answer might be east. Do you see that?
Okay.
So be very careful about thinking that the study is a survey question. Right? The study is to find out if it's equally bad. The survey question is, what shore are you on?
Okay.
Does that make sense?
Mm-hmm.
So don't get those too confused. Okay, because whenever you do a hypothesis test, it's always yes or no for the study. But the survey question is not usually a yes, not often a yes or no question. Is that clear?
Mm-hmm.
Okay, so once we have that, what we need to do is we need to write down our null and alternative hypotheses. You're used to that. At least I hope you're used to that. And I want to give a big warning. This is where things often go wrong. And they don't go wrong because you get this chapter wrong. They go wrong because all of a sudden you stop doing the last chapters right. So first thing, we write H naught. That you're used to. Okay, so I want a big warning. If you're doing a problem from chapters 9 or 10, words are not allowed in H naught and H1. Are y'all good with that?
Yes.
Chapter 11, symbols aren't allowed. Everything is words. So in this case, what we want to find out is traffic equally bad. Well, if it's equally bad, we have a word for that. What is the word when everything is the same in statistics? We've had this, and it was a while. The hint is it was in chapter 5.
Is it uniformly distributed?
Yeah, perfect. Perfect. Yeah, a lot of people have trouble with that. But what we want to do is, do we want to find out is the distribution, so the distribution of traffic in Tahoe is uniformly distributed. Any questions on H-naught? Any questions? Okay, H1. Once you have H-naught, H1's easy. Because all you have to do is put in the word not. So the distribution of traffic in Tahoe is not uniformly distributed. Uniformly distributed. Any questions on that? Okay, a lot of people have trouble with coming up with H0 and H1 in these cases. So everyone see that's what we're interested in. Is it uniform or is it not uniform? So if it's uniform, then the traffic is all the same in all sides of the Tahoe. And if it's not uniform, then it's not all the same everywhere. Is that clear? And since we have a statistics way of doing it, we should use the statistics vocabulary to write H0 and H1. Notice there's no symbols. But again, it's a big problem of the final. I am going to ask you chapter 9 and 10 questions on the final. Okay, especially chapter 10. And if you put in words, I will take off points. Got it? And similarly, on this chapter 11, if you put in symbols, I'll take off points. It's all words. Okay, the next thing we do is I'm going to draw a table. So I'm going to draw a table. Like so. Hopefully I gave myself enough space. And in the table, I'm going to have two pieces of this table. The first piece, I'm going to call O for observed. And the second row, I'm going to call E for expected. Let me try again. Got it. Any questions so far? Okay, the observed, those are kind of straightforward. 170 in the North Shore, so I just type in 170. So let's do this. Except it won't let me, just a minute. Now, 170. And then there were 212 in the South Shore. And then in the East Shore, there was 110. And then in the West Shore, there was 108. Any questions on that? Okay, so again, those are the observed. Those were the values that we observed in the survey. Okay, so now we can do the expected. The expected is what would you see had H not been true? Okay, so take a look at this. We had 600 total cars that we looked at. If there was a uniform distribution, how many would we expect to see in the North Shore?
150.
Yeah, 150. Because if it's uniform, they should all be the same. So you just divide by 4 because it's 4 categories. And 600 divided by 4 is 150. You're always allowed to use a calculator, by the way. So 150. How many would you expect to see in the South Shore? 150. It all of a sudden becomes easy, doesn't it? How about in the West? How about in the East Shore?
150.
150. And the West Shore? 150. Any questions so far? Okay, so now what I need to do, and you're used to this, is we need to use a calculator. This is really important. So now I'm going to reshare because I need to get a p-value. Now that I have my data, my observed and my expected, which is what you need for this chi-squared. This is, by the way, this is called, I should write this down. It's really important to know the name because I'm going to test you on that. I'll put it in red because it's so important. Chi-square goodness of fit. Okay, we call it that because we say, well, is it fitting the uniform distribution or is it not fitting the uniform distribution? And that's why it's called goodness of fit. Okay, it doesn't have to be uniform, by the way. There's other distributions we'll look at and we'll see that in a bit. But this is a chi-squared goodness of fit test. All right, next what we do is we go to our calculator. So now let me pop in the calculator. Okay, so you can see the calculator, hopefully. So what we need to do is we're going to go to Stat, and you're used to this. We're going to go to Edit. And we have 2 columns, rows, columns, whatever you want to call them. I'm going to clear each of those, clear L1, and let's clear L2. And then I'm going to type in for L1 the observed. The observed, if you remember, was 170. 212, 110, and 108. Any questions on that? Then I'm going to type in the expected, and that is 150, 150, 150, 150. And I believe this is one of the cases where you have to put in integer values because you can't have a fractional number. So make sure you round if you're doing a new calculator. If you divided by 4 and didn't get a whole number, then you round to the nearest whole number. All right, so now this is the hard part for all of you. You got to say a little prayer, you got to cross your fingers and hope your calculator can do it because not all of them can. So we'll see at least for the 3 of you, and I'm not sure about the rest of you watching this as an online video. I mean as a YouTube video. But I'm going to go to Stat and go to Tests. And this is, we're getting towards the end of the class, right? Hopefully you see that. Okay, so because we're getting towards the end of the class, it's towards the bottom of the list. It's a lot easier to go up than down to find the bottom. So you will see, and it might be a different letter, you might see this little, looks like an X, but that's actually a Greek letter chi, squared GOF test. Do you all see that? So let me ask you, do the 3 of you, Milagros, Elliot, and Susie, do you see it?
Yes.
Yeah?
I had to program it in this morning.
Oh, you already programmed it in. Okay. So you were lucky enough that you figured out how to program and how to make it work.
YouTube.
Yeah. You got that link that I sent?
No, I just got on YouTube.
Okay. Yeah, because on Canvas I have a link to the YouTube how to program it. But if you found it yourself, that's good too. Okay, because some calculators have it. This is the only place in the entire class, this particular test, that not all the calculators have it. And a weird thing happened is that the older versions didn't, and then Texas Instruments realized they needed it, so then they put it in. So that's why from looking at your calculator, I can't even tell you until you turn on your calculator and look. Okay, so I go enter. So if you're using a newer version, this is what you're going to do. Observed is L1. If it doesn't say L1, you got to do second one. Expected is L2. Again, if it doesn't say, then type in second 2. DF, that stands for degrees of freedom. And the degrees of freedom is always one less than the total number of categories. And here, there was a North Shore, South Shore, East Shore, and West Shore. Is that clear?
Mm-hmm.
So there's 4 categories. So how many degrees of freedom do we have? 3. If you programmed it, sometimes most of the programs do this for you, but if it's given, you just have to do that part. But how hard is it to subtract 1? I still don't know what the point of the color thing is, but ignore the color. Any questions before I hit calculate? Okay, so I can hit calculate. And there we have it. Okay, chi-squared. Okay, by the way, we have a new distribution. We have had, if you remember, the binomial distribution, the uniform distribution, the normal distribution, the t-distribution, and there's our 5th distribution called chi-squared distribution. I am not going to get involved and get into the mathematics of what it is, because it's pretty hard, too hard for this class. But you can trust me that there's a different function that gives you that shape for chi-squared. And what we need to know is how to use it in calculator. You got a dimension mismatch error. There's a possibility that you had maybe too many items in L1 or L2. You just got to hit enter once or something like that. Go back to your L1 and L2 in your edit mode and make sure you have the same number of numbers in L1 and L2. There should be 4 in each. Oh, if it's labeled L5 and L6, that'll do it too. You might have made the mistake to hit the delete key once. That kills you. So you do it with L5 and L6. Okay, the p-value, is a p-value 5.61? Is that our p-value? What do you think? No, p-value could never be 5.61. What is a p-value?
0.000000056.
Yeah, it's approximately 0. Is that clear? So the p-value is approximately 0. It's as close as you can ever care about to 0, right? Notice I did not give a level of significance. You don't need one here. And usually one is not given for chi-squared because now we're talking high technical stuff and everyone understands p-values. Any questions on that? So the p-value is small, and usually they'll just cite it as less than 0.0001. That's how it's usually cited, and that just says it's tiny. Sometimes they'll go 3 decimals or 4 decimals, but it's less than 0.0001. So because it is, let's see what we get to do. So let me go back to my whiteboard, and I can go text. And remember we had the tiny p-value. So it's time to write down a conclusion, and you should all know the conclusion when the p-value is that small. I'll start the first word there. Any guess on what's the next words?
Is statistically significant evidence?
Statistically, and I'm going to even write strong. Maybe even very strong, so I can really brag about it. Statistically significant. When you have such a small p-value, you need to brag. Evidence to conclude that, and all you have to do after this part is just retype H1, probably without the capital and the distribution. of traffic in Tahoe is not uniformly distributed. Okay. And by the way, if you know Tahoe, you know that it's not. Any questions on this?
Is there a limit of categories that you can have for this?
I don't know. It depends how tired your fingers get. So not really. There might be on the calculator. I would never test you on, a dozen categories. Usually somewhere in between 3 and 10. You could actually use it for 2. But with 2, you just can do a z-test, a 2-prop z-test. Does that make sense?
Yeah.
So you don't really need it for 2, but more than 2, pretty much what you use. That's a good question. So there's no official limit statistically. As long as your expected values, notice our expecteds are all 150, those are all bigger than 5. And they all have to be bigger than 5 or you can't do this test. Small sample sizes are never good. Any other questions? Any other questions? Okay, ready for another example?
Mm-hmm.
All right, let me erase this so that we can do another one. Okay, so a study was done. And by the way, just a warning, if I ever say a study was done, it doesn't mean a study was really done. I made it up. But a study could have been done. Do you agree with that? Okay, so a study was done to see if there was a difference in the distribution of cars for men and women. Okay. So we want to say, well, does it matter, right, for whether it's gender or not gender? Of the 200 men surveyed, 70 owned a foreign car, 110 owned an American car, and 20 didn't own a car. Of the 300 women surveyed, 110 owned a foreign car, 158 owned an American car, and 38 didn't own a car. Conduct the appropriate hypothesis test and provide your interpretations. Okay. Wait, what would the p-value have to be, say, that the null hypothesis is true? Okay, so your question, sorry about that, I didn't see it until now. If you remember in our class, the null hypothesis never decided to be true. If you ever say the null hypothesis is true, that we have evidence, statistically significant evidence to show the null hypothesis is true, you're wrong. Got it? Yeah, only the alternative hypothesis. We're testing to see if the alternative hypothesis is true or if we don't have enough evidence to show the alternative hypothesis is true. Okay, does that make sense? And there are reasons for that, but the math is pretty hard, so I'm not going to go over it. Okay, but what I do want to do is talk about this one. Now, this one is different than the last one. How is this different than the last one? And not just because it's about cars. But why? What's the big difference between this one and the last one in terms of the survey and the data collected? Yeah, here it's 2 different populations, and we're not trying to say, we don't have some distribution we know about to see is it the same as what we know. We have 2 different distributions, and we want to find out if those different distributions are truly different or are they really the same, or different populations. We want to find out if the different populations have the same or different distributions. Is that clear? Okay, so what we need to do, first thing I want to give you the test that we're going to be using, and this is not the same test that we just used. So the name of the test is still chi-squared. This is chi-squared week. Test for homogeneity. So let's see how how good you are at English. Anyone know what the word homogeneity means in English?
Similarity?
Yeah, are they similar? Okay, are they the same? Right, homogenized milk means that everywhere in your bottle is going to be the same. Bottom and the top are the same for homogenized milk. I don't know if you've thought about that. It's all mixed up. Okay, so the question is the distribution the same for the two genders? So we want to find out, are they homogeneous? Does that make sense? So that leads us to H0 and H1. So let's write them out. Okay, I want to let you know something. When we did the chi-square test for chi-square test for goodness of fit, the word distribution was in there. Do you remember that in H0 and H1?
Mm-hmm.
If you don't have the word distribution, I will take off points. Got it? There's a very small variation for homogeneity, and that is, it's not the word distribution, but the word distributions, because we're looking at two distributions. So let me start it out. The distributions of car ownership are the same for men and women. Any questions on that?
So the only difference in between this one and the first one is that on this one we're looking at two different populations.
Yeah, we're comparing populations instead of saying, does this population have this distribution? Okay, and then there's going to be a big difference in the way we do the calculation.
Okay.
Okay, huge actually. So, but the H0 and H1 are really similar. But the difference is, again, we're saying, is this distribution the same as, are these two unknown distributions the same as each other, versus is the distribution the same as some known distribution like uniform? So H1.
Okay.
So what I did is I copied and paste, because what's the one word?
Not.
Put in not. Let's stick it in just after R. So the distributions of car ownership are not the same for men and women. Any questions on the idea here? Any questions?
Just to reiterate what you just said then, so the previous test, we're comparing to a uniform distribution or a normal distribution. Here, we're comparing the two to one another.
Yeah.
Okay, thank you.
Yeah. Uniform, normal, and I'll give you an example of some other known distribution, and we'll see what I mean by that.
Okay, thank you.
Where here, we don't know anything about either distribution. We're not trying to say, is it this thing that we already know? It's just, are they the same or not?
Okay.
Does that make sense?
Yeah.
Okay, so now what we need to do is we need to go put the data in. And you're used to that, right? So I'm going to go and share my desktop. So this one, we don't have observed and expected. We're just going to have observed. We're going to have two columns of the observed. Is that clear?
Mm-hmm.
So I'm going to go, and I got a new share. And I'm going to go to my calculator. I'm going to go back to stat, edit. I'm going to get rid of what I had before in L1 and L2. And then I'm just going to let the first column, it doesn't matter which one you put, but let's call the first one men, since that was listed first. So we have 70, 110, and 20. And then we have, 110, 158, and 32. Any questions on putting the data in? Okay, so now what we do, this is a button we haven't really been playing with much, is now we're going to go, in fact, we've never done it in this class. We're going to go second matrix. And that's right there. Any questions so far? Okay, then we're going to go to edit, hit enter. Here we, the first number is number of rows, and the second number is the number of columns. So here, if you remember, we had how many rows and how many columns?
2 columns and 3 rows.
Yeah, actually, I made a mistake. We did, actually, sorry about that. You didn't need to put it into L1 and L2. That was a waste of time. Okay, but we can have 2 columns and 3 rows, or you can go the other way around. You can go, it might be easier to see on the screen, to go 2 rows and 3 columns. Might fit a little better. You can go in either direction. Sorry about it. Didn't need to put in L1 and L2. Instead, you put the numbers in here. So that was, again, 70, 1, 10, and 20. Sorry about doing the extra work I didn't need to do. And then we had 110, 158, and 32. Ah, missed. Always want to look to make sure that you typed it right. There we go. Any questions on getting the matrix put in? Okay, it's matrix A. So now I go back to stat, and I go to tests, and up arrow because we're towards the bottom. And this time it's going to be chi-squared test. No GOF. This is not a GOF test. No good as a fit. Any questions on that? I hit enter. Observed should be A. Expected could be anything, but B is easy. Color never matters. So it's very easy to use, and you hit calculate. Any questions before I hit calculate and leave the screen? Okay, let's hit calculate. And here we have our test statistic, which is chi-squared, and that's 0.2658 or so. And then the p-value is 0.8756. So what do you think with that p-value?
Looks pretty big.
Mm-hmm. And when the p-value is big, what does that tell you?
You fail to reject.
Yeah, fail to reject, and we have statistically insignificant evidence, or we have insufficient evidence. Either way. It's a lot of ways of saying the same thing. So now let me go back, because now we have our p-value, which is usually the point, and we also, again, the test statistic, when they ask you to put the test statistic, we had that number too. But here it's going to do p-value, and I'm going to look at the answer to this. So there is statistically insignificant evidence to, I like to type it in, make a conclusion about whether or not, and then just retype H1. The distributions of car ownership are the same. And since I said whether or not, then I can just go for the same. When you have insignificant evidence, you can get away with this. If you have significant evidence, then you're going to say they're not the same. Whether or not the distributions of car ownership are the same for men and women. Any questions at all about the conclusion? Most people find this chapter pretty easy, pretty gentle, but it's not an easy week. How come?
Project 2.
Because of the project, yeah. So that's why I kind of lightened up this week. If the p-value is below 0.1, we'd say the alternative hypothesis is true. Actually, you don't say it is true. You say you have I'd say 0.05 is more standard, but if it was less than 0.05, you would say there is statistically significant evidence to support the claim that it is true. Do you see the difference? We haven't proven, you can't say that, you can't say it's true. We can only say we have evidence to support the claim it's true. And that's important. Okay, because we don't know for sure, but we're pretty comfortable saying it. Do you see the difference? Okay, so now let's go ahead and do another one. So speak now or forever not see it, or until you go to the YouTube, because it's about to be erased. Got it? Gone. Okay, let's do another one. Little biology example. Okay, 70% of all Steller's jays nest in pine trees. 20% nest in aspen trees, and the rest nest in other places. A biologist observed 250 Steller's jays that were given a special strength gene. I can think of them as like GMO Steller jays. Okay, and then tagged to see if the distribution is different for Steller's jays with that gene. This is a very typical thing that is done in biology research, is that they do some genetic engineering and then they take a look to see what happened. 201 of these tagged Steller jays nested in pine trees, 37 nested in aspen, and the rest nested in other places. Conduct the appropriate hypothesis test and provide your interpretations. Okay, so I have a couple questions for you guys. First, okay, what type of test do we need to use for this particular example? What can you tell me? What's the name of the test we're going to use?
Looks like a GOF.
Okay, yeah, this is a GOF because notice a survey question is what kind of tree were you in? And the answer might be aspen, which is a word. Okay, we don't have two different unknown populations. We have a known population and an unknown population. Does that make sense? We know everything about regular Steller's jays. Here's a trivia question. Do you guys know what a Steller's jay is?
No.
Blue?
Okay. Those in Tahoe, you better know what it is. What is it?
Is that a blue jay?
Yeah, well, it's not a blue jay, but it's what almost everyone thinks is a blue jay. The birds that are blue in Tahoe, those are called Steller's jays, not blue jays.
Oh.
Blue jays are actually different. They live in different areas. Our jays are Steller's jays. Okay, but you don't need to know that for this class. Okay, so what we need to do, since we now know that this is going to be a chi-squared goodness fit test, is we need to write down a null and alternative hypothesis. You're used to that. And I like to write down the name of the test. On the final, you can get partial credit just for writing down the name. Chi-squared goodness of fit. Any questions on that? Now we can write the null and alternative hypotheses. Go a little bigger. So H naught. And very similar, what word has to be in it? Distribution. The distribution of nesting places for, I'm going to call them GMO birds, is the same as for regular birds. Any questions on that? Then I can go H1. And what's the only difference?
Not.
Yep, is not the same. Copy and paste is wonderful for these kind of problems. Sorry if you're writing on paper and pencil, but it happens. Any questions on that? Okay, so next what I need to do is I need to create my table. And what do we have? We had pine, aspen, and other. And then I can go to so the first one, remember, is observe. So I'm going to put an O. And we observe that this is the easy one in this case because we're told. We had 201. Then we had 39. How about the next one? How many do we have? How many nested in other places? 10. Because we had 250 total. 201 plus 39 is 240, and there's 10 left. Okay, then we have to get to the expected, and that one takes a little bit of thinking. The E shouldn't take thinking. Okay, so now, how many would we expect to have in the pine trees?
175.
Okay, and how'd you get 175?
70% of 250.
Good, good, good. A lot of people have trouble with that, but it's 70% of 250 is what we'd expect. So 0.7 times 250 is 175. Any questions on that? So there's actually a little math to do, nothing too hard, but you can do a little bit. How many would we expect to see in aspen trees?
50.
Okay, yeah, 20% of 250 is 50 because 0.2 times 250 is 50. And the rest, well, again, we have 250 total. We've already accounted for 225, so there's 225 left. Any questions on the observed and the expected? So there was a little work to do here. You know what? Because I don't have it on the original question, I need to write it down. So 201, 39, and 10, 175, 50, 25. Once I share, my screen's gone. So now let's go to our calculator. And we're going to go to Stat. We're going to go to Edit. Erase what we had. And then put in our numbers, 201, 39, and 10. Notice that we're bigger than 5, so we're good. If you have a number that's not bigger than 5, then you worry. Okay, 10 is even a little bit small, but we're going to go for it because in our class we're calling it bigger than 5. So 175, 50, 25. Any questions so far? We've done this before, so I'm going to go a little faster than before. I'm going to go to Stat. I'm going to go to Tests, and then chi-squared GOF. Enter on that. Observed is L1, expected is L2. How many degrees of freedom?
2.
2, because there were 3 different categories. Take away 1, you get 2 left. So 2, color I don't care, and calculate. And what do you see about the p-value?
Very small.
Yeah, very small. Not as small as that first p-value, but still small enough. 0.00048. So definitely small enough to reject the null hypothesis. So let me go and type it out. Again, I'm going a little faster this time because it's the same as that first example. So now, let's go text. There is statistically significant evidence to conclude that the distribution of nesting places for GMO birds is not the same. Okay, so what does the chi-squared value indicate? That's a really good question. Do you remember we had a test statistic with like a z? So I'm going to draw a picture in a bit. It's the same idea, but it's chi-squared instead of z. So I'll show you a picture of it. Let me finish this off. It's not the same as for regular birds. All right, so now I'm going to draw a picture. You know, the picture actually does not necessarily look the same because it's not normal. This is actually different. And the first thing, by the way, everything's positive in chi-squared. And there are different views of the chi-squared. This particular one is going to look like this one. Okay, so chi-squared looks a little different than a normal distribution, doesn't it?
Mm-hmm.
But it's still a distribution. And what we got is a chi-squared value of, what was it? Let me get my calculator again. About 15. So that's that value right there. And the area to the right of that value that's our p-value, which was 0.000, and then I don't remember the next number, but something, let me find it.
4.8.
Yeah, so I'm just gonna call it 5, I'll round. Good enough. Does that make sense? Okay, so that's what's going on. It's always the same kind of idea with statistics, but the shape is a little different when you have chi-squared. Okay, any more questions on this? All right, let me go to the next example. Next example is slightly different. Okay. Is there a relationship between the day of a week the person was born and the type of smartphone they own? Okay, it's kind of the astrology kind of idea, right? I don't know if y'all believe in astrology, but this is how you would test astrology, right? This day of the week instead of, you know, the astrological symbol or something. The table below shows the results of a study that was recently done. Conduct the appropriate tests and provide your interpretations. So we have day of the week, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And then we have iPhone, Android, or other. Any questions so far? All right, so now what we need to do is we need to understand this. Does this look the same as one of the two that we've already done? The two types. What do you think? Second example, similar. Yeah, but not quite the same. It's not quite the same. Okay? There's an issue with this. Not comparing two different distributions. We just want to see if there's a relationship between one aspect and another aspect. Do you see the difference? We also have 3 categories, not 2, in three rows, not 2. So this is not a homogeneity. Does that make sense?
This is one person looking at 2 variables.
Yep, and they're both qualitative.
And they're both qualitative.
Exactly. This is different. This is going to be called a test for independence, which is a test that was done in the firefighter article that I showed you. But now we're going to actually hand do it. And it's still chi-squared. Today is chi-squared day. So this is chi-squared test for independence. So because of that, we're going to have a null hypothesis and alternative hypothesis. And H0 is that day of the week of birth and smartphone type are independent. Any questions on that? Okay, and then H1. Just copy and paste. Any guess on the one word I'm going to change slightly?
Not.
Not, or even easier, just drop the in. Because there's a word for not independent. It's called dependent.
Yes.
Okay, so just a note, see the word independent and dependent? If you're doing a test for independence, those have to be there or I will take off points on your final. Got it? Okay, because this is a test for independence. Any questions so far? Okay, the next thing I'm going to do, as you're used to, is I'm going to share my calculator. The interesting thing is that in terms of like the language and stuff, I think homogeneity and goodness of fit are really similar. But it turns out in terms of the mathematics, homogeneity and independence are the same. Okay, I'm not going to explain why. So I'm going to go, whoops, I don't need to go stat. I'm going to go to second matrix. And then I'm going to edit A. And then if you remember, there were 3 rows. And there were 7 columns. Any questions on that? Okay, now I just type in all of the values. So that's a lot, so I can go kind of quickly. 75, 72. Then we have 68, 77, 70. Then we had 86, 80. Okay, then we had 120, 111, 131. Then we had 125, 118. And we had 124 and 101. Ah, I missed it. try again. 1, 2, 4.
And on the first one, you put 10.
Did I? Okay, let me get to that. Yeah, the problem is for some reason the keyboard doesn't. I put the buttons in, and for some reason didn't type them. Okay, and then I have 45, 52, 44, and then we have 50, 57, 46, and 52. Any questions on entering your data? And as I mentioned, the mathematics is exactly the same as homogeneity, so we can do the same thing. I can go to stat, I'm going to go to tests, I'm going to go up to chi-squared test. I'm going to enter. Observed as A, expected as B. And then I go calculate. And we get a p-value of 0.7 or so. By the way, would that be a surprise?
No.
Do you think day of the week you were born on has anything to do with the phone that you have?
No.
Probably not. Probably not. I made up these numbers, but I tried to make it like reasonable. Okay, so high p-values shouldn't be too surprising unless you're one of those like superstitious type of people. So that's what we get. And now let us go back and put in our conclusion. So we had a big p-value. When you have a big p-value, what's the conclusion? There is
statistically insignificant.
Evidence to make a conclusion about whether or not day of the week of birth and smartphone type are, and it turns out since we do whether or not, it doesn't matter if you write independent or dependent for this one. If there was significant evidence, you have to write dependent. So I'll write dependent. Because whether or not gives you both ways. Any questions at all on this test for independence? Okay, it's used a lot to find out if there's any relationship between two things. It's a very common test that people will use. And I want to remind you that this is used solely for qualitative variables. Okay, sometimes you have quantitative and you make them qualitative by have intervals or something. But this is for qualitative variables. All right, so let me do the next thing since it's 7:13. I missed one more time. And that is the secret word. And the secret word is chi. And by the way, you pronounce it chi, looks like chi. But I don't know, I'm not the one that made this thing. It's a Greek letter. So are there any questions at all? Any questions?
I have a quick question about our project.
Okay, let me stop share so that we can see each other.
That I don't know if anyone else is interested in hearing about, but it has to do with our level of significance, and we're in a forestry project. So when I looked it up, it said sometimes it's 0.05 and sometimes it's 0.1. So should we just look at our type 1, type 2 potentials and draw our own conclusions?
Yeah, you're supposed to do it you're supposed to explain from the type 1 and type 2 how you're doing it. And
Okay.
Elliot, I know you had a question I didn't say. There is statistically significant evidence. Okay, so again, you never ever say you have evidence to say the null hypothesis is true. Is that clear, Elliot? So you cannot say there's statistically significant evidence to make the conclusion that day of the week of birth and smartphone are independent. So that's never okay. But this is the time to make the mistake. The final exam is not the time to make the mistake. So all you can say is you have insignificant evidence to make. Basically, I wrote a whole lot of fancy stuff that meant just we know nothing. That's all I wrote. Does that make sense? The fancy way of saying we just don't know anything. So it's a really good thing you asked me now, because this is the time to make mistakes. You don't want to make it on the final. Never, ever, ever accept the null hypothesis. Okay, other questions? Yeah, so you decide on your alpha based on type 1 and type 2 errors. And you should do that before you even look or collect your data. Do you see that?
Yes.
In fact, you could write, if you haven't collected your data yet, you can start writing your project. Put that part in right away. Do you see that?
Yeah, we have our data.
Okay, you have your data.
Yeah. Okay, that helps a lot. Thank you.
Okay, other questions? Other questions? And as always, if there's no questions, we can say goodnight. And I'll be checking the discussion, especially the project discussion forums, but also the Q&A forum pretty often. Tomorrow, of course, I teach from 11 to 3, so outside of that time. And Friday, I teach all day from 9 till 3 without even a 10-minute break. So it's going to be a tough day. So don't expect any kind of help on Friday during the daytime.
Larry, if we get the draft in like really, really late, like 2 in the morning tomorrow, is that a problem for you?
Oh, that's fine. That's fine, because I'm not going to be looking at it until Thursday.
Okay, great.
But I also do first come, first serve.
Okay.
So I look at your emails, and if I have 6 and you're last on the list, you're going to be last to get the feedback.
Okay.
Because that sounds fair, doesn't it?
It sure is.
What could be included that would impress you in Project 2? To really understand the standard error, that's a biggie. Okay, and not just to, and another one is not just to write down the conclusions in the way I put them on the quick little summary sentences, to fully explain it in a full paragraph instead of just, there is statistically significant evidence to make the conclusion that blah, blah, blah. Then you go on and talk about why you care, what matters, what's it going to do for you, that kind of thing. Does that make sense, Elliot? Yeah, so a lot more than just to say there's statistically significant evidence or insignificant evidence to make the conclusion that, I don't know, whatever it might be. You need to go on that. So again, tell me why it matters. What decisions will be made by your client after having looked at the result? Okay, confidence interval also. Okay, confidence intervals tell you something different than the hypothesis test. They actually give you a range of values. How are you going to use that range of values? Whereas the hypothesis test is a yes/no. Any other questions? LaGrasse or Elliot or Susie? Okay, good night, Susie.
Good night, thank you.
All right, good night, Milgras and Elliot. Okay, well, have a good night. And for all of you who are watching this as a YouTube video, make sure you send me that draft, hopefully by tomorrow night, so that I can help you out. And always happy to answer any questions you post on the project discussion forum or the Q&A forum. And you can email me your draft, but you should post your questions, is how it works. So have a good one.